All right, welcome to the second video on scientific notation. Okay, quick reminder, scientific notation is a notation used to express very small or very large numbers as a product of two numbers. Product meaning multiplication. It is in the format a times 10 to the n, where a is a number between 1 and 10, and n is an integer. Remember, integer is a positive or negative counting number. 1, 2, 3, 4, 5, negative 1, negative 2, negative 3, negative 4, negative 5, and so on. A must be between 1 and 10. All right, the entire first page is a review. Okay, the second page is kind of where we're headed with some things this week as our second week of scientific notation. All right, go ahead and let's follow along, right, please. So here we go. Is the first number in scientific notation? It is not, okay? The first number is 17.6. That's not between 1 and 10. The second number is in scientific notation. We have 6, that's between 1 and 10, and 17 is a integer. All right, the second one is not, because it's not 10 to the n, it's 5 to the 10, okay? And that is not in scientific notation. The third one is, the 9 and the negative 2 both work. The third one is not, another 5 snuck in there. All right, that's a quick review on numbers in scientific notation. Okay, example 2, we are going to convert to scientific notation. So what we do is we take the first three numbers. We forget about everything else. We write down 5. Sorry, that's the elevator going off repeatedly. 8, not 2, but 3 because of that 9. We are going to place the decimal place between the 5 and the 8. So I'm going to put it between the 5 and the 8 up here and after the 2, and we're going to count how many times we had to move the decimal place. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So it's times 10 to the 13th. But Mr. Saffel, everything after that, the three numbers you highlighted in blue, where did it go? It's too small. We rounded it off. It's gone. All right, next example. Here we have a very small number. We're going to have a negative number in our exponent. So we're going to go ahead and write down the first three numbers. 2.54 times 10 to the. Now we got to count. Okay, our decimal place is now between the 2 and the 5. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So negative 10th. We moved that decimal place 10 times. All right, converting to standard notation. I know I'm going fast, but remember, this is all review. We're going to write down 4, 5, 9. We are going to move the decimal place 7 times. 1, 2, 3, 4, 5, 6, 7. That's where our new decimal place is. We're going to add in the extra zeros. So I added in 5 zeros, not 7, 5, because I had to move it past the 5 and the 9. So I'm going to rewrite the number as 4, 5, 9, and then it looks like 5 zeros. Put in the commas. There we go. All right. Now, let's go ahead and do it one going the other direction, a small number, 7, 9, 8. This time I'm going to move it to the other way. 1, 2, 3, 4, 5, 6. There's my new decimal place. I'm going to add in 5 zeros this time. So it is 0.00000798. I often put the first zero in front of it. That zero doesn't really matter. All right, so write in scientific notation. Okay, 250. Okay, this is 2.5 times 10 squared. Because if I start the decimal place there, I move it once, twice. So then, this is 2.5 times 10 to the first. This is 2.5 times 10 to the 0. And if we keep following the pattern, 10.5 times negative 1 and 2.5 times 10 to the negative second. So as you notice, we move the decimal place one time each way, and we have to change our exponent. All right, that was a super fast review of what we learned last week. Okay, convert the following to scientific notation. Okay, so this is a little bit weird. 87.1 times 10 to the 7th is really close to scientific notation, but it's not in scientific notation. This has to be 8.71 times 10 to a number. Now, I have to think to myself, what did I do here? I made the first number smaller by a factor of 10, so I need to make the second number bigger by a factor of 10. So I'm going to change that from 10 to the 7th to 10 to the 8th. If you don't believe me, go type both these into Desmos and see if they give us the same thing. So 87.1 times 10, I already forget, to the 7th, okay? And then we're going to type in 8.71 times 10 to the 8th. Those numbers look the same to me. Well done. All right, now at this time, similar problem. The decimal place started here. We have to move it once, twice. So this number is going to be 9.84 times 10. Now we made this number on the left smaller, 984 to 9.84. So then we have to make the other number bigger to accommodate for it. Again, go use your Desmos to check it out. All right, which number is greater? Interesting question here. The first two on the left are in scientific notation. Okay, 4.57 times 10 to the negative 4th or 7.58 times 10 to the negative 5th. The first thing we look at is we look at the exponent. Here, the only thing that matters is negative 4 and negative 5. Which number is bigger, negative 4 or negative 5? Slow down and think. Negative 4 is bigger. So the answer is 4.57 times 10 to the negative 4th. Even though the 4 is smaller than the 7 and the negative 4 and the negative 5 is a little weird to think about, negative 4 is smaller. If you don't believe me, change them to standard form and then compare. All right, let's look at the second example. Oof, that's not in scientific notation. I can't compare these numbers. So I'm going to change this to 8.57 times 10. I made the number on the left smaller. The number on the right is bigger. And we're comparing this to 5.54 times 10 to the 6th. Well, here, when our exponents are the same, it doesn't matter. We don't have to, we just look at the other numbers. 8.57 and 5.54. 8 is bigger than 5. It is greater than. Well, that's a bad greater than symbol. Let's make a better greater than symbol. All right. Common housefly weighs 1 times 10 to the negative 3rd. Well, a domestic cat weighs about 4 times 10 to the 3rd grams. How many times greater is the weight of the cat compared to the weight of the housefly? So how many times greater? I don't know how many times I can say this. We do division. Okay? So 1 times 10 to the negative 3rd. Whoops. I wasn't even thinking. That doesn't go on top. The bigger number goes on top. How many times greater? Okay, so it's going to be 4 times 10 to the 3rd over 1 times 10 to the negative 3rd. And our answer here, if we do this, 4, I have to put in my fraction first. 4 times 10 to the 3rd divided by 1 times 10 to the negative 3rd is 4 million times bigger. If you think about a cat's not very heavy. That shows you exactly how heavy or how light a housefly really is. 4 million houseflies weigh the same as one cat. All right, next problem coming at you. Okay? This is some simple thinking. Okay? We're going to do this without a calculator. We're going to talk about this in class a little bit. It's okay that it feels a little bit weird here. Do you notice how we have 7 times 10 to the 7th plus 2 times 10 to the 7th? Well, when we're adding things in the same, with the same exponent, 10 to the 7th in this case, we can just do the math that it tells us. So 7 times 10 to the 7th plus 2 times 10 to the 7th would be 9 times 10 to the 7th. Okay, it kind of makes sense. We're going to do some light calculation here without a calculator. All right, now here with subtraction. 12 times 10 to the 5th, that's not in scientific notation, but that's okay. We've got 12 times 10 to the 5th. We've got 3 times 10 to the 5th. 12 minus 3 is 9 times 10 to the 5th. All right, now here, I'm going to reorder things. 4 times 3. This is all multiplication. These symbols are also multiplication. All right, hold on one second. Okay, times 10 to the 5th times 10 to the 4th. So now, what is 4 times 3? Well, that's just 12. And what is 10 to the 5th times 10 to the 4th? Go back to your exponents. We add those exponents. It's going to be 10 to the 9th. But, oh man, my answer is not in scientific notation. So I have to change this to 1.2 times 10 to the 10th. When I make the first number smaller, the first number got smaller, I have to make the second number bigger to compensate the change. All right, now let's go ahead and look at this. Just like we did before, we're dividing things with exponents, sort of. 9 divided by 3, what is that? 3. 10 to the 8th divided by 10 to the 5th, we subtract exponents. 3 times 10 to the 3rd. Okay, that's some light calculations without a calculator. We're just going to think about this week. It's not really going to be something we have a lot of assessment questions on, but it's something we're just going to kind of use our brain power to think about. All right, thank you for following along, and I will see you soon.